as people are still kind of trickling in, we want to outline a little bit what we have in store for you guys today. So today is all about predict, plan, profit, mastering pricing in the AI era. So kind of the intersection of pricing and new technologies. Obviously, there's a lot of hype out there that we want to address, but also maybe want to give a view on. So if you go to the next slide, Ingo, I'll introduce our speaker, Ingo, here today. So Ingo is the co-founder and managing director at Buynomics. So he has over 14 years of experience in pricing. He also developed the Buynomics method, which is a unique AI solution that I'm sure we'll touch on in the next 30 minutes. I already see Sanji asking a question in the chat, so that's great. Always ask away, please. And he's asking whether this will be recorded, and the answer is yes. And the even better answer is it will also be shared after this. So if you registered with your email to this webinar, you will receive the recording to that very email. And also let us know if you want to have the slides sent to you. Always happy if you reach out to send them to you personally. If everyone just wants to quickly write in the chat kind of where they're from today, which country or city, whatever you want to say, just so we get a feel for kind of how international our audience is today, where everyone's coming from, and just to get a little bit of a sense of who's there. I'm myself and Paul. I'm leading the growth team at Buynomics, so contributing to content and insights. Some of you know me from conversations that we had previously, and I have a background in consulting. And if you go to the next slide, Ingo, I can introduce Buynomics as well. So Buynomics is a software provider for companies that are looking to improve their revenue management. So mainly in the consumer goods or CPG space, but also in telecoms and some software, where we deliver really a unique holistic approach, end-to-end revenue growth management with high predictive accuracy, super fast processes, and really unlock a lot of top-line value for the companies. And Ingo, if I look into the chat, it's quite an international audience here today. So I see the Netherlands in here, I see Argentina, I see faraway cities like Düsseldorf, Stockholm, Sao Paulo. So quite a good audience here today. What do you think?
Yeah, very, very happy to see that. I'm also excited about the topic. And I noticed on the previous slide here, we almost look as in real life as we look on these two photos. The only difference is the green sweater here. So not much has changed here, at least not visually, but content-wise, I think it has. All right.
A lot of things at Buynomics, of course. So show you some of that in the next 30 minutes. But yeah, please do engage in the chat. I'll answer some of the questions already, and otherwise I'll post them at the end of our conversation here with Ingo, and I'll hand over to you, Ingo, now.
Perfect. Thanks, Paul, for the introduction, and thanks everyone for joining. It's the first webinar of this year, and we're really looking forward to this one, and also to what we have ahead. I think we're preparing a good set of webinars this year. I think we had 35 last year, aiming to have something like 40 this year to make a little bit of progress there. So really looking forward to this year and doing this series and also having the conversation with you. I think we'll present the topics as we see them, maybe here and there in a bit provocative way. And if you disagree, please just write it in the chat. We're really happy to discuss it towards the end of the webinar or afterwards. Really interested in your point of view and in having a discussion on these topics, because we find them very interesting, of course. And let's get started. And today's topic, as Paul already mentioned, AI and pricing, I think two important concepts. And it makes sense to think about what happens if you put them together. And this is also really what we do pretty much all day long, all week here at Buynomics. So let's get started. And I think when you get started on AI, it's difficult to get around ChatGPT. And I just did it this morning, asked it, I would say, a simple pricing question on, as you can see, I hope it's not too tiny here to read, but let's very quickly see where it stands at the moment. So this is the current version, ChatGPT, and I asked it, I sell my product for 100 euros, my margin is 50%, and the price elasticity is -3. I want to maximize my profit. Should I increase or decrease my price? So very straightforward. And as most or many pricing professionals know, in the profit optimum, margin times price elasticity is -1. Here, the price elasticity is -3. So the profit optimal margin should be 33% and a third. So that would mean you need to reduce margin. So if you decrease the price, that would increase the profit in this example, right? It's specific to the numbers given here, but that would be the right answer. So to increase profit, you need to decrease the price in this example. And what ChatGPT does, and we're not going to go into all of the details, but essentially what it does is it gives you the right definition of price elasticity. It tells you what happens if you decrease, what happens if you increase, but it doesn't really answer the question itself. So it kind of feels like a clever student who hasn't practiced for this specific exam. And I think this is where we stand with ChatGPT at the moment and pricing. So it's really good to give like a conceptual answer. For example, if you ask it how, this is my company, I'm in this industry, that's the size of my company, that's the team I have, those are the challenges. How should I structure my pricing process? It will give you something like an 80% answer, but it doesn't really answer at the current moment actual pricing questions like this one here. What would be the profit optimal price in this case here? So this is where we are, and to get started, and this was just an example, but if you look at the field as we've done, there are of course tons of different publications, pretty much from outlets like the Harvard Business Review, having lots of articles. Here's an example of one that was just around last month. And all the consulting firms, pretty much everyone who's related to the field, will have some view on how machine learning, artificial intelligence can play a role in pricing and revenue growth management. And they cover a very wide range of topics. And I think from our point of view, if you structure it a little bit, we see essentially 4 areas where people see a potential benefit from machine learning or artificial intelligence in the field of pricing. One is as an interface. So you have a pricing solution from like maybe the current pricing solution, whether you do your pricing in Excel or some SaaS solution like ours, and a way to use something like ChatGPT would be to go from using the tool the way you manually, like you're doing at the moment, or with code, going to like a prompt interaction with the tool, and you have something like ChatGPT who then does the what you needed to be done. So you would go from doing an analysis yourself to just prompting into the system something like, please tell me the promotion ROI by promotion type for 2023, and then the system does the analysis in an existing tool. So as an interface, and that's something that makes sense. Here at Buynomics, it's not really something we focus on at the moment, but we did a hackathon when we met over Christmas, and the team made some good progress on this topic. So that's certainly a way that might make sense as an interface. In particular, probably I would expect it less important for professionals who use these tools on a daily basis. They will probably be more effective continue using the tools as they are. But people who just occasionally, maybe more senior people who just want an analysis, they can also just ask something like ChatGPT, use this tool to prepare this report for me. So that's a way that's been discussed. Another way that's discussed that I've seen more than I would expect is using something like ChatGPT or these language models to actually generate data, and sort of replacing surveys, something like a conjoint study where you in the past, or of course many still do, ask 1,000 people to understand their willingness to pay or their preference for certain features in products. And going from this and not asking 1,000 people, but asking something like ChatGPT 1,000 times. That's something we're a bit more skeptical about, because it's not clear where ChatGPT should know from what people are willing to pay for a specific chocolate bar, for example. So that's something we're a bit more skeptical. But things that are much more legitimate are then using technologies like these for data preparation. So always, if you work with data, there will be outliers or missing data, and that's already something where we're also looking into. That's already been done, where these technologies can help preparing, aggregating, and like initially analyzing the data. So that's something important. But I think the core application for our field is really the area of optimizing, price optimization, revenue or profit optimization. And the question is, how can we use these technologies, coming from something like in the example that we had, a simple way of looking at price elasticities for your products, to going to something like a holistic optimization across the different RGM levers. So maybe not just looking at a single product as in the example, but looking at a full portfolio, and also not only looking at price optimization, but looking at price optimization together with promotion and product feature optimization. So this is, I think, really the holy grail and the core, and also that's what we're most active in here at Buynomics. And let's dig a little bit deeper into this specific question. Before we do that, I think there's one important thing to understand when we think about how to do machine learning or artificial intelligence in the field of RGM optimization. I think what most are familiar with are, particularly with something like ChatGPT and other technologies, are text generation. So the way is very simplified how this ChatGPT works is that you ask it a question and it really has a string or a sentence, and the question then is, what's not the most likely, but what's a good next word? So it predicts the next word in a sentence. Similarly, if you have software that generates images, you have a number of pixels in a picture, and the question is, what's the next reasonable pixel in this picture? And this is how they complete these texts or images. And this is really the way these technologies work. For us in RGM, I think the analogy or what needs to be done is look at past shopper behavior, see how, for example, you have a market, you increase the price 10%, you lost 20% in sales. Very simplified. That means you have something like a price elasticity of -2, and then you use this, what you've learned from the past behavior, to make predictions in the future. So if you increase price another 10%, you would expect, for example, to lose another 20% in sales. So this is really how it works for us in RGM. You look at past behavior, how did customers react to changes in price or changes in product, changes in promotions, and so on, and then deduce from that their behavior and look forward what it means for future changes. And the way this really has been done in the past is by what we would say are very simplistic concept. For example, a price elasticity, but this is just an example. Other concepts that are used are I would say similarly problematic, but let's just use the price elasticity here as an example. And I think would be interested in understanding how most of you are working in your price decisions, or when you make price decisions. Probably from what we're seeing is that many are still working with having, for example, price elasticity tables that are computed by something like this regression analysis. Of course, actual regression analyses are a bit more complicated. They correct for seasonal effects and all kinds of other things. But in the end, what you're looking at is the relationship between price and sales. And let's say these are weekly sales, each one of these dots. So in weeks where you have a higher price, you sold less. In weeks with lower price, you sell more. And if you apply a regression analysis, essentially just draw this line here in between, you get the price sales volume relationship, and then you can compute the price elasticity, for example, here in the middle at price 1. And in this case, it's a -2. What's important for this type of analysis, or if you have this table, is to know that the price elasticity can change massively if you change the price a bit. So for example, in this case, if you increase the price by 10%, which is something particular in the last 2 years, that was very, very normal in many industries, is that if you increase it by 10%, your price elasticity already goes from -2 to -2.7, just because it's a different point on this price elasticity, on this demand curve here. So particularly if you're dealing with a linear demand function, as empirically most of them are, at least within reasonable boundaries, you have price elasticity changes that can be very large. So you go from -2 to -2.7 with a 10% price increase. And why are we saying this? So because what we're seeing in many cases is that teams or companies claim that they use machine learning to determine price elasticities, but there's not much benefit in just knowing this price elasticity here of -2, because it changes so quickly with a simple price change, or it changes because the price of another product has been changed. So it's not really good to just look at the price elasticity, but it's makes a lot of sense to go a bit deeper, and this is where the machine learning really comes into play, and I want to outline this very briefly here. So I think the analogy or the way to look at this is what we have with this simple example here, what we have on the left side, and probably many of you have seen this. So you have these little metal balls here in this Galton board, and they fall through these to these beds, and they go left and right with a probability of 50% each time. So they fall through and they go through a line, let's say something like 10 of these beds, and each time they go left or right with 50% probability. And then the resulting distribution is a binomial distribution here, which is very close to the normal distribution. That's the outcome here. So, and why is this important for us? It's important for us because we have a process. This is how these balls fall through the beds. And this here is the outcome that we see in the end. So we have this outcome, the normal distribution, and we have a process that produces this distribution. And in the same way, when we look at our cases, so how customers, how shoppers react to price changes or other changes in the market, we have the same phenomenon. We observe the outcome. We observe shoppers buy 1,000 units of product A, 2,000 units of product B, and so on. And this comes from their preferences, the way they make decisions between these products. And if you change, for example, a price, you go from this 1,000, 2,000 distribution, maybe to 1,500, 1,500. And this really depends on the preferences. So what we need to understand and do with machine learning here is really understand the preferences, the willingness to pay, also the behaviors, how people choose, for example, when you cross a price threshold or do something else in an actual market. And this is where we think AI should come into play. And this is what we do here at Buynomics and what we call the virtual shopper technology. And the idea is actually very simple. The implementation is then, of course, much more difficult. The idea is that we create a large number of virtual shoppers, maybe 10,000, hundreds of thousands, depending on the context, and each one of them can make an individual decision based on his or her preferences between different brands, between different sizes, product features, and so on, and also certain behaviors. So, for example, just like real people, some are susceptible to price thresholds, others are not. So for some, the difference between $9.99 and 10 is very large. For others, it's not very large. So we create these virtual shoppers, and they all have these preferences here for different brands, for different sizes, and so on. And when we show them different products, each one of them makes a decision here indicated by the color. So the pink people here buy product A, the blue ones B, and the green ones C. And if, for example, you change the price, their decisions also change. So if we keep everything stable and only increase the price, then fewer and fewer people will buy this product A here in this example, and the same with the others. And when you have an understanding of how demand reacts to price changes or other changes, you also have an understanding, of course, of all the dynamics that are going on in the market. And of course, here in the screen, you cannot really see the interaction, but it really what it allows you is, let me just quickly change my screen for this. Paul, can you now see my browser?
Yes.
Okay, perfect. So here on the screen, on the previous, in the PowerPoint, we of course couldn't show any dynamics, but here's still a simple example, but a more realistic one. So we have, we're selling peanuts here in different sizes from 1,000 gram down to 250 gram. We have competitors, competitor A and B, also selling different products, and we have different potential sizes of products. We have brands, so it's our own brand, and there's competitor brand ABC, all kinds of other brands, and we have prices, costs, and so on. And in this example, we have a number of market size of a few thousand. And what happens if I, let's say, increase the price here of this largest pack by 20 cents, go from 16.99 to 17.19, I have a price elasticity of minus 5.5. Relatively high, but this is also because it's the only product that's been changed in this market. If, for example, I also increase the price of this other product, so this is the nearest size, same brand, so it's the closest alternative, I see that I'm losing fewer units because the previously most attractive alternative has now become a little bit less attractive because it's also more expensive, and I see that my price elasticity has dropped. And of course, with this, I can really understand the whole dynamics in this market. So if I change prices, but also, and I'll just go through this here very quickly, I can also look at other things. So this is the case that I was just looking at. These are the unit sales of these 4 products. And let's say I increase my price by 20% for all of them, then I lose a certain number of sales here. If my competitors follow my price increase, I can also simulate all of these interactions because I have these virtual shoppers in the background, and they all make decisions based on the offer that's presented in the market. And I can also not just look at price changes, for example, but can also look at feature changes. So for example, if I go from 250 to 200 grams, so I do degramming instead of a price change, 500 to 400 and so on. So I'm really flexible, and it also shows me the dynamics. For example, don't have this example here, but for example, if I change the price of just one of the products, then of course I see that, as in the previous table, that I have sales going from this one product to the others also within my own portfolio. So what I'm saying is, and this was just a very short example, is that this type of technology, and we really think that this is the future here of RGM, how it should be done. Paul, can you see the presentation again?
Yeah.
You see here that with such a technology, you can really look at all the dynamics that are going on in the market. And how do you get to this? Of course, I think it's clear for everyone. If I have these virtual shoppers and they really do behave like real people, then it's very simple to get the dynamics right, because I have an actual picture of what people do. And how do I get this? There are different ways. Of course, there's all kinds of different data in pricing and revenue management. We have actual sales data from the past. We have survey data. We have panel data, all kinds of data sources. And what we always try to do is similar to what the large language models do when looking at text, is really trying to understand the relationships between words in their context and to predict what the next word is. And what we try to do is understand what are the underlying preferences, what's the underlying process that produces the observed sales. So for example, very simplified, we only have these products that we just saw in the solution for the different nuts, for our own nuts and then the competitor nuts. We have these examples, and we have different sales volumes in different weeks, for example, because different products are in promotion in week 1 compared to week 2. And because that we have different sales volumes, and that allows us to really parameterize the model, the preferences for these different nuts and for the different sizes, such that, of course, not with 2 weeks, but if you have dozens or hundreds of weeks, you can use it to parameterize and really dissect and understand how the different brands, the different sizes, and so on affect the purchasing decision of these virtual shoppers and also of the real shoppers. So this is really the idea. Take historical data, sales data, or panel data, or all kinds of other things that really, in every survey that you do, it really measures the preferences of shoppers. You use that to get an increasingly better picture of the decisions and the preferences of shoppers, and then you can use that to make predictions looking forward. And if you do it, it looks kind of like this here, very simplified. So you have, now we're just looking at a single product. These black bars here are the actual sales, and then what the virtual shopper technology produces as an outcome compared to, we did a traditional regression model that looks at the same parameters in the way that regression models do it, and you can see that the virtual shoppers are much closer to the real sales because they really reflect the dynamics and the process for how people make decisions and how they choose between different products in these weeks, and that this allows us to be a bit better in the prediction. And this is important because why are we in the end doing it? It's to make our organization stronger, more profitable, if that's what the organization is aiming for. And you can see, and I'll be back with Paul in just a second, you can see that with this virtual shopper technology, you're much closer to what really happens in reality. And also it gives you much more flexibility, and you cannot just only look at price changes, but also feature changes in products, promotion changes, all of these things with much higher precision. And that pays in the end, as you can see, that it allows you to be more precise, and with more precision, you make better decisions, and that allows you to be more profitable in the end. And just to close with the final statement, if you don't believe us, certainly should believe a real authority in the area of human behavior. We found this quote a couple of years ago. I think it makes perfect sense. So it's attributed to Sherlock Holmes. It says, while the individual man is an insoluble puzzle, in the aggregate, he becomes a mathematical certainty. And that's certainly also what we observe in our work. Paul?
Thanks, Ingo. Almost on the minute here. We have a couple of questions in the chat, so I don't want to waste time. So Christoph is asking, do you train the virtual shopper somehow? Are they the same for all the categories products, or do you use some sort of the market data as input?
They're context specific. So the ones that have an opinion on these different nuts, they can't buy cars, but they can also, to some extent, learn across similar categories without going into too much detail. But they're general features, like some of the behavioral features, what I mentioned, price threshold, they are much more common across context, but preferences between brands and specific tastes, other features, they're always very context specific.
Yeah, so we are using basically market data of the specific channel, retailer, and category to parameterize and train the model, because Emilia is also asking, does the tool model virtual shoppers down to the different channels, retailers, and various part of geographies? And the answer is yes, but you need to have the input data on a sellout level for us to do that, of course. Ideally also for competitors, because your shoppers will decide between your and competitor products. Bruno is asking how you address over parameterization inside the model. could this be one of the avenues of low error versus actual sales? It reflects the overlying data.
Yeah, so of course, overparameterization is always an important issue to keep in mind. That's without going too much into the details, you always look at the in-sample, out-of-sample. So how good is your prediction on out-of-sample, so data that it wasn't fitted on. There, if you did over-parameterize, then you will typically see there that it gets much worse. Of course, and there's lots of experience that goes into finding the right degree here. And in the example we showed previously here, it's with the same number of parameters that we use. So it's like for like better than regression models, for example.
Cool. I also answered Christoph on his question in terms of which data sources we use. So we do use any data source that has sales data. It's usually a syndicate like Nielsen or Circana, which most of our clients have anyway. But it depends really on the industry, on the specific context of the country as well. But more about that, if you want to shoot an email to me, I'm happy to answer that, Paul. First name, last name at buynomics.com. Any other questions in the chat, please ask them now. Otherwise, Ingo, let's go to the next slide because we do have some interesting ones in the pipeline. So today was our Predict Plan Profit webinar, and we have some interesting ones. So beginning of February, you will hear from Mark Campbell, good friend over at BIC, obviously a stationary company, but also a razors company, and also in different types of businesses, and really interesting view on how to build RGM. He will tell you what the 10 imperatives of embedding RGM as a mindset are. And we will also have a webinar with our friends over at Unilever in March. So stay posted for that. Check your emails, check our LinkedIn, and follow us there. Of course, recommend us to your friends and colleagues so they can also participate in that. If you have any questions, please add us on LinkedIn or do send us an email. And otherwise, I'll see you at the next webinar.
Thanks, everyone. Thanks, Paul, and have a great weekend. Bye.